When I talk with people about Metaphor and Humbug, there's a couple of questions often come up. One is, how is it that we go about building software using these tools and get such really high volumes of code that work really quickly? The other one is, can you use these tools to build tests? So I figured I'd give you an example in this video that talks about doing both of those things, and it's the same problem. So the problem we're going to look at is a part of the Humbug design, which is the Markdown parser. So for anybody who's unfamiliar with it, Markdown is the language format that the large language models use when they're streaming responses. So when you see things coming back on a web chat or whatever, that's what's happening. You're getting stuff rendered as Markdown. And it renders to HTML, so it works really well for the web. It's also what we use in the chat and the conversation view inside of Humbug. And there's some slightly strange things about it inside of Humbug. We have to deal with streaming responses. We have to be able to work out bits that are incomplete and not mess up the display. There are a couple of other things that are a bit weird though, and I'll actually show you one of them later on in the video because it comes up when I show you the conversation. I'll show you later on. Anyway, the problem is that we have this slightly unusual Markdown parser, and obviously we'd like to have some tests to make sure that it works properly. So what you've got on screen right now is you've got the metaphor file that I am going to use, or I have already used, in fact, for building the tests, and you'll see what happens in the conversation. So as always, this follows the standard metaphor approach, and you can see actually all 5 keywords being used here. If you're not familiar with those, if you go and check out the M6R AI GitHub repositories and go and look for Getting Started with Humbug, there's a whole tutorial there that explains all of this and how we go about thinking about building things using Metaphor. But anyway, so in this, we're telling our LLM that we want to be a world-class Python programmer because we'd like it to do really good software. And then we're giving it some context. And the context is all the stuff it needs to know in order to be able to do the task. So we're giving it some Python rules. Just for an example, here's actually what the Python rules are. These rules are the coding rules that we like to use when we're building the software. So it's how we like the AI to lay out the code. Some things we like it to do, some things we don't want it to do. The next part we've got is we're telling it that we want it to use standard libraries. We don't want to use anything unless we specifically tell it to use another dependency. That stops it from pulling in all sorts of random code from the internet, which makes things really complicated and more difficult to maintain. And then the other thing is we're telling it we've got some existing code, and the thing we're telling it about is the Markdown parser. This is the thing we wanted to build the tests for. So we're going to embed the Markdown parser. And then we get to the action, and the action is where we're really telling it what we wanted to do. So we're explaining as much as we can, and this is something that I find people often don't do when they're writing prompts for LLMs. They don't really explain to the LLM what they're trying to achieve. They just tell it to go and do something. The more you tell it about what you're trying to do, the more likely it is to do it the right way. So in this case, I'm explaining the problem. I've got a Markdown parser. I want to construct some test coverage for it. The tests mustn't add any new APIs. I don't want it to modify the top of the file that I wanted to write the tests for, and it's only got to use the public interfaces. And this is actually really important because we want to exercise things through the public interfaces. If you put special test interfaces in, it's not really doing the right thing. And also, one of the nice things about using large language models to build tests is they'll write all sorts of quite complex test setup to be able to exercise very small amounts of the code. It's the sort of thing that human developers never have the time to do, and frankly get bored trying to. So that's another reason why I like using AIs for doing this stuff. Then go on to explain to the AI, Markdown's got some quite complex behaviors, and rather than hard coding the blocks in the test files, I want to have the option to be able to set up external tests where I capture some Markdown that we've maybe had it come back in a response from the AI, or maybe it's some Markdown that we've actually had from somewhere else, and then we're going to have the Markdown parser construct the abstract syntax tree, so it's a representation of that Markdown that it uses inside the program. We're going to have it draw that out, and then we're going to be able to compare the two. And the nice thing about this is it means you can take actual examples of things that have gone wrong when you find them, and you can then make sure you got the solution right, and then check that nothing ever breaks again. And this is a very, very common design pattern inside of something like a compiler. So I'm borrowing this idea from there. We don't have any of this right now. I literally, when I was setting this up, didn't even know how it would go about thinking about constructing this. And then just for an added bonus, I'm telling you there's a Markdown visitor class. This is a thing that is used for doing debug printing. It's also, there's another visitor class which is used for rendering the markdown onto the screen inside of Humbug. So what this does is it walks through the tree that's constructed by the parser and actually either prints it or draws it on the screen. And so I've given it a hint that here's one that's being used for doing some debug work, and maybe it can use some elements from that to help do the activity that I want it to do. And then my usual thing with LLMs is not to tell them to go and build me code, but actually to ask them to propose a design. And the reason for that is you can have a conversation with the LLM before it does the coding, because it'll propose a design, and you can say, I don't like these bits of it, or ask it questions about bits you're not sure about, and get to the point where you iterate on it. And sometimes you discover that there's something that you're missing in the context, and you come back and build a new context, or you update the action, to update the metaphor prompt, and then try again. But so we're going to ask it to propose a design. Now, I actually ran this about a week ago, and the reason I didn't do the video sooner is because of something I'll show you in a second. But I wanted to see what happened, and so this took me probably 10-15 minutes to write this this metaphor prompt, and then we ran it, and literally this is the first time it ran. So we ended up with this conversation, and I'm going to take you into go back a little bit here. Sorry about this. I'm going to take you back to where that action is, and you can see it here. So here's the same stuff that you just saw in the .m6r file. This is actually the AI, or this is the part of the conversation which is being sent to the AI, and it's actually rendered into Markdown format itself here. So this is the bit where it's saying, here's what I want you to do, and here's an example of how that AST printer works. So that's that piece of code that you can see there. I'm not going to look at it quickly. If you want to see it, you can find it in the source code. So here's actually what the LLM did, and here's the response it got. And this sort of shows some of the aspects of what I was just describing. So first of all, it tells me, here's a design. So it says, I'm going to build you a test framework, and I'm going to tell you the approach I'm going to take. And this is great because we can have a conversation and ask it questions if we want to. So it sketches out the overall design, and then it gives me an implementation plan. And it says, what we're going to do is we're going to create a test structure, test directory structure that's going to look like this. So I've got an idea how things are going to be laid out. And you can see, for example, it's showing some examples of where you put in the markdown files and the matching JSON files that you use to match them up. So that's great. It's followed that part of the instruction. It's decided that it needs to create a special visitor class, so an AST comparison visitor class, which is using the same sort of idea as the one we got from the debug one. And if you scroll through this, you'll see it's doing very, very similar things, except it's actually collecting some additional information, which is going to be used for actually checking that the results are what we want them to be. So this is looking quite positive. It's sort of doing things that we expect to do. There's quite a lot of code here, but some of this bit is quite similar to things that we've just seen. So we can keep going, and then we get to test utilities. Now at this point, it's talking about some things that it's going to write, or some code that it needs to be able to run the Markdown parser tests. So at this point, it's going to talk about some things it needs to run the Markdown parser tests, and it's going to write some utility functions. And the nice thing is, because we have these coding rules that we've given it for the Python one, we've told it we want doc strings everywhere. It makes it easy to understand what's going on. We can get a pretty good idea of how the software is going to behave. It's following the sort of design patterns that we typically use elsewhere in the code, which is all good. And then we've got some features here that will allow us to compare what we were expecting against what we actually got from the parser, so we can check that things are working properly. And then we get on to the main bit of this, which is the main test file. So this is actually the PyTest code that's going to be used for testing this Markdown parser. Now, one of the things that this is slightly easier than maybe some other things. It knows what Markdown is. I haven't had to give it a big description of it. If I was approaching this for something that was a bit unusual, I would have given it a description of Markdown. But because Markdown is fairly well documented, it's got a pretty good idea what it should look like. And it's also got the Markdown parser code, so it can read that and work out how Markdown fits into that parser. And you'll see it's actually written a whole series of tests. It's asserting various conditions. It's written all sorts of interesting tests here to check various different behaviors within the parser. And these are unique to this particular parser. So there's some interesting things around underscore parsing. There's a few things where the parser, for example, has an option to turn off using underscores as a way of putting things in italics, because it turns out that when you're actually streaming code back, if you have software that uses a lot of underscores in function names or variable names, that causes problems. So Python typically has that problem. And so we actually turn off underscore processing when we're streaming code. So that's an unusual thing you need to do. And you can see here it's starting to structure some Markdown. You see some examples of Markdown code fragments or Markdown document fragments inside of the Python code, and it's then going to build the abstract syntax tree. So it's going to parse things out, and then it's going to check that the results match. And where we get to here is actually an example of where things were doing something slightly odd, which is why I didn't use this straight away. There was actually something, it was not really a bug per se, but it was something that wasn't working quite the way I wanted it to. If you look at this little block of code here, this test code block, what you'll see is the way that Markdown structures code blocks. And the way it does it is it uses 3 backticks at the beginning of the line and then an optional language name, in this case Python, and then it then takes that as a code block and it will actually render it as a monospace type. And so that's how things were designed on the web. But one of the problems is if the code block has 3 backticks inside of it right at the beginning of the line, then most Markdown parsers actually go, oh, that's the end of the code block, and they stop doing syntax highlighting. In fact, they start to try and process this as if it's normal text. Now, that's actually wrong in this case because we've got embedded 3 backticks here, but they're actually embedded inside of a Python string. So this is actually legitimate code. And this was the problem. This was a problem that I fixed a couple of days ago, where if we go and find a code block inside of our Markdown parsing, what we actually do is we hand the block to another parsing engine. It's a syntax highlighting engine, which is used for various different languages inside of Humbug. And it gives it to that first to see if it's actually code that's doing something like a string, or whether there's a comment that has the string that would end the code block inside of it. If it is, it ignores it because it says, oh, actually, those are legitimately part of the syntax of the Python code. They're not actually instructions to the Markdown parser to stop processing the code block. So if you've seen this or you run this on a slightly older version of Humbug, you'll find that there's some slightly weird things for the next 20 or 30 lines, but in this one, it now actually renders it correctly. So you can see more things. You can see tables. Those were added in Humbug, I think, 0.12. So you can see all the various different aspects of Markdown being used. Keep going. There's quite a lot of this. In fact, when you actually look through all of this, there's about 30-something tests that is written. Then it's finally given me a couple of examples. So it's giving me a really simple Markdown file, which is just the different sorts of headings you can have, and then a JSON file that matches what those headings should be. And this is where I was talking about, you can take a Markdown file, you can create a reference example of what it should look like, which is what will be in the JSON, and use that. So in fact, it's given some examples of how to use those as well. And keep going. And then actually, just for bonus, it actually adds this test generation tool, which is a command line tool that will take a Markdown file and actually work out what it should look like and what the JSON should look like. So it makes it really easy to create those reference JSON files to go with Markdown. What it then does is, because I've asked it for a design sketch, it actually talks about why it thinks these are a good idea. So it's talking about maintainability, coverage, ease of expansion, makes it nice and easy to add new things, regression testability, and then describes the execution flow. And one of the things I wasn't sure about, so I wanted to know how it did this, I then asked it a question interactively, which is, which part of the code triggers the use of the test fixture files, so the files I just talked about. And so it describes how this is done. So it talks about how it's parameterized in a particular way and how these functions actually make that behavior work. And at that point, I'm pretty confident this is a good approach. And in fact, in this case, it's actually given me all the files I needed. So all of those files that we just saw, that we've just been scrolling through, it turns out all of those are full complete implementations. Sometimes what happens when you ask for a design approach is it just gives you the high level version of it. It doesn't give you all the pieces, at which point you get to the end and then say, okay, now please give me all the code, which is what it'll do. But anyway, so we took these files out, dropped them into Humbug itself. It turned out that when we ran them, there was a couple of minor problems. These were to do with the way that the directory is set up for tests, which is not something we've actually given it. So you can't really complain too much that the LLM didn't do that quite right. We hadn't given it quite as much information as it needed. It took about half an hour to resolve the problems with those. And then when we ran it for the very first time, what we actually got was we got about 30 or so test passes, which is great. We also got 3 failures. 2 of those were down to the LLM not completely working out what the syntax tree should look like when it was rendered, so it didn't get those quite right. It took probably a couple of minutes to work out what was going on with those and fix them. One of them, it turns out, actually found a genuine bug in the parser. So that took probably another half hour to go and find out what was going on and resolve that problem. And in fact, that subsequently led me to change the design of some of the parser. So if anybody follows the Git histories, you'll see that change came in earlier this week, where some of the parsing structure around paragraphs and text has now been changed. And in fact, that's a really good change, because some of the things we're going to do later will need some of those changes as well. So anyway, hopefully that's given you an idea of what you can do, how you can go about doing it, and also some examples of the sort of output you can get. If you want to actually go and see the test running, you can go and do that inside of Humbug itself. All the tests are actually there inside of the source repo. What I am going to do though is show you one aspect, which is just to talk about how much code coverage we got from that. So I'm just going to switch to a web browser, and because the reports we get from PyTest come in a web browser format. Okay, so now you can see the coverage report that comes from PyTest. This is basically telling you how much software is being tested and which parts of the software are being tested. And the 2 things we're going to look at here are Markdown AST Builder and Markdown AST Node. And just to make it clear, Markdown AST Builder used to be called Markdown Parser. So when I ran that script that I've just shown you, it was called Markdown Parser, but there was another Markdown Parser that had the same name, because I'd taken 2 projects and merged 2 things together. So I gave it a new name, which is Markdown AST Builder, just so it's unambiguous. So what we're going to look at is what the tests that were written by the LLM actually did. So I've not modified anything since then. I've not added any new ones yet. I just wanted to give you an idea of what that one-time code generation actually really did. So what you can see here is that there's 71 statements in one file, 668 statements in another. And we've got pretty good test coverage for a first time round. We've got 96% of the statements in one have been covered, 80% of the statements in the other one have been covered. One of the things you can do if you look inside of PyTest is you can see these coverage results, and you can see which lines have actually been covered and which ones haven't. So you can see, pretty good levels of coverage. We can see anything with a green bar here is being tested, anything that's got a red one hasn't. But most of this file has been tested. Now, what we can always do is we can, and this is what will happen subsequently, is we'll take this file and we'll give it back to the LLM, and we'll start to tell it about the bits of the file that aren't tested and ask it to generate new test coverage for that. So I'll actually show you that in a minute, because I haven't actually done that yet, so I'll do that bit live. So we now have a new file, which I've just written, called revised tests. And what this one does is it's telling the LLM about a whole series of tests, or a whole series of functions that aren't tested properly and where they're not tested. So it's along the same sort of lines as we had before. The only difference is we're now actually going to go and give it the test framework that we saw being created in the previous run. So I'll open the system shell for this. And we will now run the M6RC compiler. Just start this going. So it's revised tests. Oops, revised tests. We're going to auto execute it. We're going to use the new model, which we couldn't use at the time. We can now use Claude 4. And the temperature is going to be the default. So that's now going to send this off to Claude. And you can see Claude is streaming back some responses. In fact, what I'll do is I'll just flip this across so you can see it in one place. So you'll see Claude is making some suggestions as to things that we should actually do to run the tests. So I'm going to let this run, and then I'm going to read through the code, and then we will see how it does when we integrate it in and what that does to the test coverage. You can see already it's actually starting to create new tests for things that weren't there previously. I spotted just there as we were scrolling that it was adding in some table tests, and I knew that was one of the areas that was lacking. So we've got some new tests being generated, and it's making some suggestions about things we should look for. Okay, awesome. Let's give this a try. Okay, so I've just read through what Claude has given me. It's given me lots of code fragments. I could actually sort of copy and paste those into the test framework myself, but I'm sort of lazy when it comes to doing these sorts of things right now. So I'm simply going to ask Claude to write them for me and just give me the whole modified test program. So let's do that now. Okay, so what it's doing is it's giving us a patched version of the Markdown AST builder test program. So I'm going to leave this running because it's probably going to run for a couple of minutes. Won't be super exciting to watch. But if you were watching carefully, you'd see that it's actually interspersing some of the new tests in with the old ones. And it's following the structure pattern that it had previously. So we'll just leave this to run for now. Okay, so Claude has given us a full version of the file, and what we're going to do is we're going to save that file. And in fact, because everything's already protected, what we'll do is we'll simply overwrite the previous version of that file. Okay, we'll open a terminal and see how that works. Okay, so we've got a couple of failures, but you can see we have quite a lot of new stuff that has been created. So let's see if I can work out what was going on. These may actually be genuine bugs, of course. So, but we can see that we've actually got a lot more tests there. I'll come back and take a look at this in a minute. What I do want to do, though, is go back and revisit the test report, and we should be able to see that we've got significantly larger amounts of test coverage at this point. So let's go and do that. Okay, so this is the screen we had previously, and we had 80% test coverage on that file. We'll just refresh it, and now we have 91% test coverage. We've also gone to 99% test coverage on the AST node as well. So you can see that we've gained quite a significant amount of additional test coverage, and obviously I've got a bit of investigation work to go and do. So I will dig into that and see how that goes. Okay, so I've just been investigating the two failures we got from the new tests, and it turns out that there's nothing actually particularly wrong. So I'll just run the tests again. What you'll see is, I mentioned before there was some code that would actually print the syntax tree so you could see it, and that's what we have here. So you can see the two failing tests, but you can also see what's failing and why. So in the first instance, the very first one is looking at this document tree. So we've got a document node, unordered list, list item, paragraph node, and then you'll find there's 5 text children underneath it. And what's clearly happened is that the LLM assumed that some of these texts and the single blank spaces would be put together on a single line. So it's expecting the continues on this line to be in the second row rather than the one it's actually in the third row. So that one's not so significant. And in fact, there's probably a change coming in the parser design anyway that will actually merge all of these together before it gets to this point anyway. So there'll be a minor change to the code, but there's nothing actually wrong there. And we could very, very quickly fix the test and have it fully passing. In fact, I'll do that in a minute just to demonstrate the point. Second one, it's a very similar situation. You can see what it's actually failing is it's telling us that it's expecting to see a heading, a paragraph, a list, and another paragraph. And if you actually look at what's being printed here, you'll see here we have this extra one called a line break node. And that's actually something that wouldn't normally appear in Markdown per se. And it's done specifically to get some of the rendering right. All that we need to do to actually fix that is change that 4 to a 5, because in fact we're going to have five elements there. So I'll go ahead and make those changes, and we'll see what the test run looks like then. So I've just made the changes that I had previously described. So I fixed the assertions so that they actually line up with the behavior of the parser, because the test should represent what the parser does, not what the LLM thought it might do. So it's taken me a few minutes to actually sort those out. If we now run the test again, you'll see that everything is green, all the tests are passing. In fact, if you run PyTest VV, it'll give you the full details. So you can see all the tests that were run and see the results. So what we've done is we have built a completely new set of tests. We've actually added an additional 11% to the test coverage. We're now up into the 90s, which is really good test coverage. If this was something we were doing by hand, we'd probably be getting quite happy with that sort of level of test coverage. And it's taken, I'm just looking at the time now, it's like 18:25. You can see from the conversation, we started the conversation, it's in UTC, so it was actually at 18:01 that we started the conversation with the LLM, and it probably took 10 minutes before that to actually set up the Metaphor script. So in total, it's taken about half an hour, maybe a shade over half an hour from starting the idea of we want to actually add this additional test coverage to actually having additional test coverage across the code. I've also very quickly looked at some of the tests, and it's actually starting to give some pretty good test coverage. One of the things that's always useful to do, or interesting to do, is to see how much code we got this time and how much was added. So we can do that now. And you can see that this has, all right, it's deleted 3 lines of code. It's added 548 lines of new code in the last half hour to actually get that additional test coverage. And in fact, what I've seen before when I've used this sort of approach for building test coverage like this is you can actually iterate it towards 100%, get very, very high degrees of test coverage very, very quickly, because the LLMs will generate sort of this large amounts of code that's necessary to be able to exercise quite small amounts of code inside of these libraries. So it demonstrates some of the power and some of what you can do. But anyway, hopefully you got something from the video, and I hope you join us next time. If you're interested in what we're doing, you can check us out at m6r.ai, visit the website. That's got links to all the Git repositories. It's got links to YouTube and Git and Discord, or you can subscribe to the YouTube channel. Thank you for watching.